So this is something that affects a very, very large number of people. And one thing that I found interesting when I was reading this report, because I was really originally just getting the number, but I was kind of curious, so I read through the report. It's also mentioning things like cybercrime as a service, which starts to sound very similar to our normal crime groups. But it's a different environment because everything's done digitally. So there are things like forums that are selling malware or botnets, which we're also not going to talk a huge amount. But it sort of develops in things you have to be concerned about start to be similar to the physical world, even though it's it's all digital. So the attacks we're looking at, some attack individuals, so these be like a malware on your computer, like ransomwares, things like that. And we'll talk about that in the second presentation. So some target organizations, and then some even target nations. And we can think of examples for each of these. I think that there's a little bit of that in the second presentation. And one of the things we want to talk about is defense measures for the first of those, targeting individuals. Because there's a lot of basic things you can do which can help mitigate and prevent those kinds of attacks. And then just to round up some things from that report, I included this diagram. You can see malicious scans has an estimated daily activity of 80 billion. That's another one of the very big differences that you see in physical security and cybersecurity. If, say, you're talking about physical security, you usually can't just walk up to some compound and look at all their defenses and stuff. But in cybersecurity, because everything's connected, you can do all this scanning and try to see what's going on in the networks without actually being there. So that's one more thing I wanted to talk about that. So now we'll start doing vocabulary, because that is everyone's favorite thing. There are four sort of terms I have here, just to sort of categorize different kinds of attacks, to sort of get a general idea of what these look like, how we would group them. And for physical, and we'll go more detail in just a second. Physical attacks, which are caused by the physical environment, and we're sort of going to crossover between cybersecurity and physical security there. Human, and this is one of the big ones. So if anyone's heard of like social engineering, that would fall under this category. Because at some point, humans are going to be using the software and the hardware, so you have to account for that. And then operating system is failures caused by or within an operating system. So this doesn't necessarily mean it's the fault of the operating system itself, just something that is in that category. And then the last one is network. Failures caused by. So for physical security, it's a very broad group of things we're looking at. We're concerned with the implementation of the system, which can be anywhere from a bunch of servers in some warehouse somewhere, or thermostats, which are going to end up in thousands of homes all across the world. So things we would ask ourselves when we're talking about physical security is what could go wrong? Like if we have a bunch of servers, are they somewhere where someone could just walk in and get access to them? Are they somewhere where a tree could fall down and crush the servers? Do the thermostats give up valuable data if they just fall on the floor? Can someone open up the thermostat and gets information from that? And especially if we're talking about things like phones, one thing a lot of people are concerned with is if I get a phone, can I unlock it? And you'll hear this come up all the time, with law enforcement and with cyber criminals who get access to a phone. One very important security feature is making it so if they get that phone, they can't unlock it easily and get all the personal data inside it. So that's another thing that we're worried about when we're talking about physical security. Because it's very easy to assume, well, it's digital, we don't have to worry about what happens when someone gets the device, but it's very important. Like in this lab, we have these computers sitting here. Obviously, we don't want people to just be able to log on and someone's account as long as they have access to the physical device. So next one is human, and as it says, at some point humans are going to interact with the computers. This is a problem. Humans make mistakes. So one of the major things that we want to look at when we're talking about cybersecurity is how easy is it for a human mistake to compromise a system. And it's pretty much inevitable that somebody is going to make a mistake, and it's also pretty much inevitable that there's going to be someone who has the ability to cause damage to the computer. And what we want to worry about is what protections are there in place to mitigate this. So do we just give everyone in the company access to all the computers and just hope that they don't tell anyone? That's probably not going to work out very well. So the operating system acts as a middleman between applications and hardware. You're all probably very familiar with this screen, Windows. This is the operating system we have in all the lab computers, so we'll get to know that later. And this, like it says, just acts as a middleman. So when an application wants to do stuff, it has to go through the operating system. And then when we're talking about it in just this sort of these four categories sense, we want to ask questions like, how does the software interact with the operating system? What can it do? And what might a developer do that could cause problems here? And this maybe isn't as applicable if you're not like an information, I guess like an information officer or something like that. But there are also things you could talk about here that are very basic, like say, I have a folder and I don't want, maybe like I'm sharing a computer with someone and I don't want someone else to access the folder. Questions like that. And then finally, network. So networks, they connect different systems together. And this can take a pretty wide variety of frames. So questions we would ask ourselves is, how is the network set up and who has access to what? So in this is just a little diagram from the internet, but we can even look at things like, say we have important stuff here, and we want to ask, well, sure we can block someone from getting in from here, but if someone can get in from here, then we still have a problem. And this is what, at the very beginning, I was talking about with internal attacks. You have to give the people on this side some level of access to your system because they're the ones designing it to some extent. So you have to worry about questions like that when you're talking about networks. And I think this is my big question slide, because I know I just said a bunch of words, so I want people to actually sort of think about it and maybe give some examples of things we might be worried about with each of these categories. So if anyone has any suggestions.
Fire, like there be fire, somebody.
No. So yeah, if it catches on fire, and one thing you'd want to worry about there is if the system catches on fire, then what is the data completely lost, right? Because we don't want that to happen. So you want to worry about some kind of backups, and then you also have to worry about where those backups are, because obviously if the backups are right next to the originals and it all catches on fire, we haven't accomplished much.
Could be clicking someone's fingerprint.
Yeah, absolutely. So I guess put that as biometrics.
They mentioned it in our reviews.
Yeah, so that's absolutely something. And it can be kind of difficult to have with biometrics, have your system recognize people who own the device, but not somebody who even just looks similar, like if for eye recognition and stuff. Now, what about human? I'm sure we can have lots of examples for human error.
Pressing the wrong key, or
Yeah.
accidentally deleting something.
And that's actually a great example, because if you have some software or you're some company and someone can press the wrong key and cause a bunch of damage, that's a big issue. Even if that's a trusted person, we have to assume that there's going to be some level of error. And one good example was the Hawaii missile alert. That is something you would consider a cybersecurity issue, because the system was designed in such a way, at least from what came out of reports initially. I know there was a bunch of weird developments with that, but what was supposedly happened is they designed the system in such a way where the person accidentally sent out a real missile alert thinking they were sending out a drill. So that's another thing, you sort of want to ask yourself, like, how easy is it for someone to make a big mistake, because you have to assume that that's going to happen. So it's another good example of another. Let's see. One other thing that I would put in there was things like, how many of you have heard of phishing? We'll talk about it a little more
Yeah,
detail in the
it's
next
covered in
presentation.
portions.
But that's something that I would also put, like, if you're,
Let's just say more like malicious
yeah,
focus, as of these deleting by accident or hitting the wrong button, I would assume was not maliciously intended. But the stuff like phishing or creating these other things is,
and that sort of would be under the category of how easy is it for someone to be tricked.
yeah.
Like, do you have some sort of like educational thing with the company to prevent people, like making sure people know what these things are?
Yeah.
So that's also
Oh, yeah, I was just gonna say, one common theme you guys are gonna notice in cybersecurity is that almost always humans are the weakest link. So it's gonna come up again and again.
So operating systems is a little harder. But anyone have anything for networking?
What is it when a computer crashes? Is that the operating system? Or is that?
Yeah, so a crash can occur for a number of reasons, and it can be a little technical, so sort of. Basically what you would have with a crash is the programmer has a number of things that they expect the program to do. So we could say, for example, I expect someone to put their name here, and if you don't make sure that the input someone puts in matches that, then what can happen is the program can try accessing resources it shouldn't, and that's when the operating system will tell it to crash. So I think that's a good example too, if you want to put balance checking into something. And that's a very big thing in cybersecurity. A lot of the bugs that are found can fall under some category of the programmer is accepting input from the user and they're not making sure it looks like what it should. And that's a very, very important theme that we see all over the place.
Do we want to cover SQL injections? Or is that-
No, not solicitation. Anything else? I would consider that physical.
What about the developer? Like, I know Windows, when they open up a new version, it's always vulnerable to something. They always have to release patches for it.
Yeah, so that's what we call a 0 day, which basically means it's a bug where the attacker finds it before the developer does. And that's another thing that comes up a lot.
So many companies, for example, I think Apple or Google also, now they have 0-day vulnerability analysis. So if a person can come up with that, they have a very hefty prize, reward from that.
Google will give thousands of dollars if you find a serious vulnerability in like Google Chrome or something. They take it very, very seriously. And that's something I think in Jay's sort of discussion presentation might come up a bit. Because how companies reward people for hacking can get very complicated ethically. Some companies, if you do some kind of hack, breaking their system, they'll file a lawsuit, they'll go after you
Throw the
for
hook
it.
at you.
Some companies will give you money for it. Some companies are not clear which one they'll do. So there can be some ethical issues there.
Depends on the arrest you.
All right, what about network? This one's kind of harder for like a normal computer user though.
Well, like if the network gets overloaded and it'll just bring it down and then
Absolutely.
it gets stuck.
That's what we call a denial of service attack.
Okay.
And I think Shanique, will you talk about that in one of your presentations?
I will, but you can talk.
Yeah, so basically what happens is when someone's doing a denial of service attack, they send as many requests as possible, and they'll use usually something like what we call a botnet, which is a bunch of computers, especially IoT devices like thermostats and stuff, which don't have as many security precautions on them. They'll have a huge network of those. It can be in the thousands of devices. I believe the largest one is in the hundreds of thousands of devices. And then they all have them sent traffic, and the service just won't be able to handle it. And so that's what we call a denial of service.
Well, that happens during testing sometimes. It used to, especially, right? We used to have that when we were trying to test maps and all of that. Yeah, and it would just.
And that can happen under normal usage as well. So one of the really interesting things about denial of service is figuring out whether it's normal usage or someone's starting to mount an attack. Because obviously you want to be able to do something before all your systems go down. And so the last thing that I would put under here is the internal attack that was mentioned a couple of times, because that's another thing that comes up a lot in the network. Because people who are working for the company are going to have some level of access to the company's internal network. So you sort of have to worry about what they're able to do with that access. So the things we were talking about before was just sort of a nice way of categorizing it. The CIA triad is something that is actually